Hello everyone. In last video we have seen the location of tetrahedral and octahedral voids, and we have seen how many tetrahedral and octahedral voids are present in a unit cell, isn't it? Now in this video what we are going to see, we are going to find out the relationship between the radius of the octahedral voids and the radius of surrounding atoms. I told you earlier that the radius of the octahedral voids totally depend on the size of atom. We can assume this thing that this groove which will be created will be totally depend on the size of these atoms. If I increase the size of the groove will also increase. If I decrease the size of the surrounding atom, the size of the groove or the void will also decrease. क्यों चाहिए हमें? Why we are finding out this radius? The reason is that most of the time it is observed that most of the time the lattice point of the of any of the crystal is made up by the anions क्योंकि वो बड़े होते हैं, and the cations are fitted into the octahedral and tetrahedral voids. फिर से सुनिए, what I mean to say here is कि क्रिस्टल के जो कॉर्नर्स हैं वो तो बनते हैं, यूनिट सेल के कॉर्नर्स आर मेड अप बाय द एनायंस विच आर बिगर एंड द केटायंस विच आर वेरी स्मॉल comparatively they are fitted into the grooves of the crystal या voids of the crystal. अब we have seen about the two types of voids, octahedral and tetrahedral. Now we have to find out whether these small atoms, cations, will be fitted into the crystal, into the grooves or the voids created by the surrounding atom, or they will not be fitted. So we want to know what is the size of this groove so that we can predict whether that cation can be fitted into this groove or not, or void or not. That we want to know. If the size of the cation is bigger than the given void, then it will not be possible for that cation to be fitted into the given void. That we are going to find out. So first of all, we'll find out the relationship between the radius of octahedral voids, that is indicated by the small r, and the radius of the surrounding atom, which will be indicated by capital R. तो इसका radius will be indicated by the capital R, and groove का radius या void का radius will be indicated by small r. तो let's start with the octahedral voids. Start करें. तो remember that when I have drawn octahedral voids, how I have drawn that? One ball, two ball, three ball, lower side, and above that I have kept one more layer, but in the opposite way, that is two balls के ऊपर there was one ball, remember, and one ball के ऊपर there are two balls. I hope you remember this thing. One more thing I have told you to do, that is pick the center of these balls, upside ball, downside ball, upside ball and downside ball. Then I asked you to connect these balls. Okay, and then we connected the center of these downside and upside ball with each other. Remember, this was the way. This way we came to know that this is octahedral void. How they are connected, how we are visualizing it. Now, can you see these four balls? 1, 2, 3, and 4, which I have connected with these four. Okay. Now this is this way here. You can assume this thing कि कुछ ऐसे tilted हैं. If I do this way, if I tilt them in front of you like this, so what I will observe here is one ball upside, one ball downside, upside, downside. So this way these four balls will come out. Can you see them? So this will be the idea behind that. We are going to make them in front of you, and then this radius we are going to find out. Okay, so this is the radius of the groove or the void, which is called octahedral void, and this is the radius of the atom which is surrounding this octahedral void. तो basically आप निकालने वाले हैं relationship between capital R, which is from this to this, and the relationship between R and R, which is this to this. So this we are going to find out. So obviously we can see here there is a triangle A, B, and हम इसे C ले लेते हैं, इसको C ले लेते हैं. So this is what A, B, C triangle. So you can understand here in triangle ABC, which is a right angle triangle, and we can apply the Pythagoras theorem into it. AB का square will be equal to AB, BC का square and AC का square. So I am writing it here. AB square equals BC square plus AC square. Okay. What is AB here? This is R and this is R. Radius of two atoms here. So this is 2R square equals, what is BC? BC, capital R and a small r. So this is R plus R, or AC is again R plus small r. So R plus small r. So this is a square, this is a square. If I total them, add them, so this will be getting 2R plus R ka square. Okay, this is 4R square equals 2R plus R square. 2. Okay, so this is, if I remove this square, तो अंडर रूट लेती हूँ तो क्या मिलेगा मुझे? √2 equals R plus R. Okay, so if you solve these, what will be getting? R को कॉमन लेके R को अलग कर देते हैं. So R will be, small r will be √2R minus R. √2 की वैल्यू you have to put here 1.414 minus 1. Okay, so what will be the answer? R तो कॉमन ले लिया, ठीक है. तो इसका आंसर क्या निकला? दिस इज 0.414 R. So this is the relationship between small r and capital R, जहाँ पे this R is the radius, this R is the radius of this void and this capital R is the radius of this atom. जितना ज़्यादा ये radius होगी, as the radius will increase, the groove or the void size will also increase, and more size, the bigger and bigger atom can be fitted into this void, isn't it? So this way we can derive the relationship between how they are related with each other. This is called radius ratio of the octahedral voids versus radius of the surrounding atom, or I can write it in this another way. Radius ratio of octahedral void is small r capital R is equal to 0.414. This is the radius ratio. In some of the books it is also given radius of the cation, this small r, यहाँ पे cation fit होगा. So this will be R plus or R minus. So basically R minus we are replacing by the capital R. So you can write it in another way also, that is radius ratio is the ratio of the cation, radius of cation and radius of anion, which is always 0.414 for octahedral voids. We can calculate it for the tetrahedral voids also. Let's do it. So here is your diagonal. Okay, in this diagonal we will be lying one octahedral void at the 1/4 position. I told you each diagonal is having two octahedral voids, and they will be here and here, half ka half. So these two are falling at the 1/4 distance of AB. तो AB का 1/4 distance पे we will be getting what? Tetrahedral voids. तो उसके लिए हमें AB चाहिए. AB कैसे निकालेंगे? AB के लिए we need AC, and this though we want that this is A. This is already we want, this is the edge of the unit cell, remember? So there is one triangle we have here and two of the lengths are unknown. तो इसके लिए we have to create one more triangle. I am taking this A, B, C, D ले लेते हैं इसको, है ना? तो this triangle A, B, C, A, C and D, okay? In triangle A, C and D, इस 8CD में what is AC? AC का स्क्वायर will be equal to AD का स्क्वायर प्लस DC का स्क्वायर. AD का स्क्वायर क्या है? Edge का स्क्वायर, because this is the edge of the unit cell. This is what? This is also edge of the unit cell. तो AC का स्क्वायर will be equal to 2A square. तो AC will be √2A, isn't it? AC will be √2 a. So here we have root 2a. ओके, तो ये मिल गया हमको. अब this is we knowing, this is we know. तो करते हैं. तो we are going to take triangle A, B and C this time. Okay, in this triangle ABC, what is this AB? AB का square will be equal to BC का square plus AC का square. Sorry, AC का square. BC क्या है? BC is A का square. This is root 2 A का square. ठीक है, तो ये क्या हुआ? A square plus 2A square, that is 3A square. AB का square. तो AB क्या हुआ? What is AB? AB equals root 3A. So this way we have calculated root 3A. Okay, तो ये आपको लेंथ मिली root 3A. But where our tetrahedroid is lying here. अब जरा assume कीजिए, this is your tetrahedroid and this is the atom with which it is connected. तो actually we need this. हमें ये चाहिए है ना. We know that this is the radius of surrounding atom and this is the radius of tetrahedral void, isn't it? So let's find it out. Root 3 by 4a, 1 by 4 part पर we are getting our tetrahedral voids. ठीक है, so let's do it here. ये तो हमारा पूरा recalling है just because we have already done this. We have calculated this part using this triangle. We have calculated this part using this as a triangle. ठीक है, now actually the things start. What is that? Now this time we can understand this thing. Root 3a by 4 divided by 4 is equal to what? Root 3a divided by 4. I can write down it as small r plus capital R. Isn't it? Can I take this? Small r by capital R. Isn't it? तो लिखते हैं root 3 by 4a equals AD by 4, जो कि क्या है हमारा? स्मॉल r प्लस कैपिटल R. तो रूट 3a by 4 is small r plus capital R. But here a I don't want now. I have to convert this a into r so that I can utilize it in my calculation. So this a is what? This a is the edge of the cell, edge of the unit cell. अब इस a को what type of cell it is? Unit cell it is FCC. Okay, and FCC के लिए for FCC के लिए R is equal to a upon 2 root 2. This we have already done. तो R equals to a upon 2 root 2. तो a की लगानी है ना हमें, तो a equals to 2 root 2 R. Capital R I am taking because what is the edge? The edge is made up by the atoms. This is bigger atoms, है ना? Corner atom से बनेगी edge. That is why I am taking capital R. Okay. So I am starting from capital R equals. So here it is root 3 by 4. A की जगह I am using 2 root 2 R, which is equal to R plus R. This way, isn't it? अब ये तो गया root 3 by 2, ये आपका root 6 by 2. ठीक है, R equals R plus R. तो अगर आप इसे कैलकुलेशन करेंगे root 6 by 2 R minus R equals to R. क्या हो गया? root 6 by 2 minus R minus, I'm shifting it this side, R equals small r. And when you will calculate it, you will find that R, small r, will be equal to 0.221 R. And this is the relationship between tetrahedral void and the radius of that atom which is creating tetrahedral void. Or I can write it in this way. Small r upon capital R equals 0.221. किसके लिए? For tetrahedral void. Or I can write it this way, R plus and R minus is equal to 0.221. This way we can calculate the relationship between the octahedral void radius and tetrahedral wide radius. Okay, so this way we are doing it. One numerical we are taking here, which type of questions may be asked from this particular part. So let us understand let us see one question related with this topic. Okay, so here I am writing down one question and we will attempt it together. Okay, here is the question. The question is that the radius of an anion in an ionic solid is 100 picometer. Anion की radius is given to you, means you are given capital R, because anions are making the lattice point of the crystal, that is they are present at the crystal lattice point, and the cation is going to be fit into the voids. So anion का radius is capital R, which is given 100 picometer. What they are saying is find the radius of cation. आपको radius of cation find out करनी है, वो radius बताइए जो कि फिट हो सकती है इनटू ऑक्टाहेड्रल वॉइड्स एंड टेट्राहेड्रल वॉइड्स. ओके, जो इनमें फिट हो सकती है. तो यू हैव टू टेल टू टाइप ऑफ रेडियस, टू रेडियसेस. यू हैव टू सजेस्ट ऑक्टाहेड्रल वॉइड्स आर कंपैरेटिवली बिगर देन टेट्राहेड्रल वॉइड्स. तो अगर दैट रेडियस द एटम which is we are taking here anions that can be fitted into tetrahedral wise, तो obviously वो octahedral में तो चला ही जाएगा because octahedral is bigger one. तो one by because he is asking, तो we will be giving them suggestion कि भाई ये can be fitted into octahedral wise and this can be fitted into tetrahedral wise. So basically what you are asked to find out are radius for octahedral voids. If you get the radius of the octahedral voids, you can find out the radius of that atom which can be fit into that octahedral voids. तो वो radius और उससे कम radius वाले atoms can be fitted into the octahedral voids. So let's find out what for the octahedral voids, what is the relationship between the small r and capital R. So for the octahedral voids, we know that R equals 0.414 R. This is the radius ratio. What is the radius given to you? 100 picometer. So 0.414 into 100. So picometer will be 41.4 picometer. Should be the radius of the atom which can fit into octahedral void. But this size of atom cannot be fitted into tetrahedral क्योंकि वो थोड़ा छोटा होता है. So let's find out कि tetrahedral voids में फंसने के लिए occupy करने के लिए what should be the radius of atom. So what will be the ratio? The ratio is for the R for tetrahedral voids. R for tetrahedral voids we can calculate. R equals 0.221 capital R. What is this? 0.221 into 100. वो तो already decided it. That is picometer. The answer will be 22.1 picometer should be the radius of the cation. If you want that cation to be fit in the tetrahedral voids, तो ये तो दोनों में फंस जाएगा. It can fit into either tetrahedral or octahedral, but this cannot fit into both क्योंकि ये छोटा होता है. So this type of questions will be asked to you related with octahedral and tetrahedral voids. Radius ratio is the ratio between these two radius, the ratio of the radius of cation and anion. This you have to remember. I hope it is clear to you and this will be helpful for you to understand how to apply this concept. If you like this video, hit the like button, share it and subscribe my channel. Thank you very much.